All right, everyone. Good evening. It's now about 6:36, and we're ready to get started. So welcome to yet another of our meetup for June. Today, I'm looking forward. We have an interesting topic, something that a lot of people would like to hear about. So hopefully we're going to have a really good time. As usual, I'm going to take you through just 2 minutes of introduction, and then I'll pass you on to our speaker for today. As you know, this is becoming one of the major meetup now in Dallas metropolis. We're somewhere around almost 1,600. And in every of our meetings, we're trying to make it, better than the last one. So today we have someone that I think you guys are going to enjoy. All right, so our speakers, our sponsors, you already know Brent Langston, he's not going to be here today. And then our speakers or the company sponsoring us today is Harness. And their website is there, harness.io. And we have the person who has been, who made this meeting possible. His name is Bryan Feuling, and he's here with us as well. And my humble self, also one of the main sponsors. My name is Damien Igbe, and I'm the CTO of Cloud Technology Experts. And what we do, well, as I always say, people know about AWS, but not many people have heard about Cloud Technology Experts. So basically, we're into cloud training. We specialize mostly on Kubernetes admin, then Kubernetes security, microservices with Docker and Kubernetes, and also AWS Solutions Architect. And for today, I have just a few announcements, and then we're going to move on. So as I always say, we're always looking for speakers, we're always looking for sponsors, we're always looking for help. And recently, Himansu joined us. He was here in the last meeting. He helped out a lot, and he is continuing to help us. So if you have some time to help us organizing the meetup, always feel free to let me know. And of course, if you also have something to share with your colleagues in terms of a project you've been working on, also do let me know. So next meeting is going to be on July the 15th. And going on, we're going to try to have two speakers since we're mostly online and there's not much socializing we can do when we are doing online. So we should be able to host two speakers in our meetings. So next one, we're going to plan for that. And it could either be online, completely online like today, or we could have a combination of doing it online and in class, depending on how things go. All right, so before I pass the microphone, I'm going to just introduce our speaker. His name is Bryan Feuling, and he will introduce himself when he continues, when he started the presentation. He's a solutions architect at Harness.io, and the topic is Verified GitOps. You may have heard of GitOps, but probably not Verified GitOps. So Bryan is going to tell you what all that is all about. This talk may be up to 1 hour, depending on how interactive you guys are. It could be shorter, it could be longer, but normally we have 2 hours for our presentations. So once we finish, we're going to stop there and then look forward to the next meeting. All right, guys, I hope you are staying safe. Again, welcome to today's meetup, and I'll pass over to our speaker, Bryan. Bryan.
And real quick before he takes over, if anybody has any questions, feel free to throw them in the chat, and I'll make sure to poke Bryan and get them answered.
Perfect. Really appreciate it, everybody. Yeah, and then I'm actually going to pause 2 or 3 points as well, just to kind of take any questions that either have been in the chat or if you have any saved up at that time. So really appreciate you guys jumping on the call and walking through this with me. So what we're going to be covering today is a concept called Verified GitOps. Honestly, I'd be surprised if anyone has ever heard of this topic before. It's extremely new. It comes out of some of the drawbacks that GitOps brings, which we'll cover some of the pros and cons, but this is going to be different than GitOps, hence the tagline, the Beyond GitSync, right? So what we want to do is just make it go a little bit greater than that. But it is in the same vein as GitOps. It is the idea of using source code management to be significantly more than just storing application code. So that's basically what we're going to be covering today. So for the agenda, the first part we're going to do in GitOps, and I know you guys had a GitOps presentation before, so this will probably be review for a lot of you if you watched the last one. So we're going to do an overview of what GitOps is. I'm going to actually show you some examples of what GitOps looks like. So I've run this internally, and I'll show you some of the screenshots that I have and explain some of the screenshots for the examples for GitOps. We're going to cover some benefits and some drawbacks of GitOps. And then once we get to that point, we'll actually pause, and then we'll do some question and answer related to GitOps, just to make sure that as a high level concept, it makes sense. We're also going to cover some prerequisites that are required for GitOps to be put in place. The next thing we're going to do is actually kind of jump to like a 50,000 foot view, because it's important to understand what we're trying to accomplish when we're looking at this, right? It's going to be way more than just how do I get a manifest deployed into a cluster. We need to look at our entire SDLC, our entire CI/CD process, understand all of the different nuanced pieces that come together for it, and then how do we fit that together? Some of it is going to be automatable, some of it won't be. And we need to make sure that we're weighing the pros and cons associated to that. So we're going to hit the pieces of the puzzle. We'll talk about where GitOps actually plays into those pieces. And then we're going to jump into the Verified GitOps portion. We'll do an overview of what Verified GitOps is. And you'll see a difference between the two, GitOps and Verified GitOps. We'll show you some examples of what Verified GitOps is. And then we're going to go into benefits and drawbacks of Verified GitOps. Again, we'll do a pause at the end for some question and answers. Talk about some prereqs that are there as well. And then lastly, we're going to hit on some CI and CD initiatives. So the goal of that last bullet point is I need to take the data that I've got from the GitOps, the pieces of the puzzle, and the Verified GitOps, and I want to take that back to my own personal project, my company, my role at my company, my team at my company, and how do I actually employ this? So you'll see some of those initiatives on what to consider, or what you may already be considering, put into words that we can kind of consider and go back to. So for a GitOps overview, essentially what is GitOps? So GitOps is actually a term that was coined by a company called Weaveworks. It was intended to be the practice of codifying an application and infrastructure specs in a declarative language. So something like a JSON or a YAML or XML, but hopefully you're not doing that still. But that was the intent. And then you would store and version that code in a Git repo. And then what you would do is you would use like a webhook or some type of triggering based off of a Git event, and then that would deploy the changes automatically. It sounds great, and it's honestly a pretty lofty goal. And we'll kind of go through some of the prereqs, some of the benefits and the drawbacks, because this gives a higher level understanding of a good desired end state that actually GitOps doesn't get to yet. So we'll kind of walk through that. But as anybody who's ever worked with a Git repo before knows, this is what it looks like when you have one person who is trying to implement some form of, maybe a trunk-based development or something along those lines, where, GitOps would essentially be triggered based off of that, especially if you're new to how to use Git. So you typically start off with really well-intentioned comments in your Git messages, right? Like I'm creating a main loop and timing control. I'm enabling config file parsing. And eventually you're like, this is really annoying. I don't want to add more and more comments. So eventually it gets to like miscellaneous bug fixes. Like that is not definitive. But we all know those people who add foo and bar to their comment messages, right? Like we all know that process. And eventually you get to the point of just typing something in because you have to put something in there, but it doesn't really benefit. And that's essentially why Git blame was invented. So this is essentially what we see as a potential problem with just leveraging a Git repo itself. So here are some examples that we're going to walk through on what GitOps actually is in practice. So the first one is just a diagram, an understanding of how GitOps works. So you'll have a developer or DevOps engineer or some level of engineering. They will do certain things on their actual laptop, and then they'll run, or their desktop, they'll run a pull request to a Git repo. Once that pull request or whatever the event is approved, maybe merged to master, whatever that might be, there will be a webhook that will auto sync down to the application and or infrastructure. So in the case of Kubernetes, we're talking about the leveraging Terraform for the infrastructure change based off of the Terraform repo is affected through a PR, or maybe we've got some Kubernetes manifest, Helm charts, customized files, whatever that would be, that's affected by a PR. And those things would actually trigger a deployment, or what is called an auto sync. It's just a fancy term for a deployment down to the endpoint. So this is kind of what it looks like. This is the idea on the left-hand side of a customization setup for Kubernetes. We've got our base, we've got our 2 overlays for production and staging. And then this is obviously a customization file on the right-hand side. It's just a hello world customization application, but this is running something on my local computer. What we did first is I ran a kubectl get, and I ran that against my cluster that I was going to be deploying to, so I could see all the namespaces, the pods, if any deployments, config maps, services, things along those lines. And then what I did is I set up in my VS Code an automated trigger that basically said on save, run this command. And that's essentially what GitOps is. I'm going to affect a file, I'm going to save that file, and when it's saved, then I'm going to execute a command of some kind. That's the high level understanding of GitOps. And that's actually what I did here. So what this leads to is I change the file at the top. When I change the file and I hit save at the bottom, it just auto executes that kubectl apply-k, which is the new kubectl CLI that runs customized. And then it actually creates or changes those different pieces as part of the customization portion. So that's essentially what GitOps is. Now you can operate GitOps in a vast variety of ways, and we'll kind of walk through some of those at high level. But the concept is, and Damien actually brought this up earlier, the concept is the push or the pull model. So this is a push model where I've got a external appliance or an external process that will then go and execute a command against something that is external to itself. So I'm pushing my deployment down. So another alternative would be like GitHub Actions. That is another way to do this. A pull model would be something like an operator or a controller inside of the cluster that is actually looking up against what my Git repo is and checking that for changes. And then on a change, it pulls the deployment down, right? And that's, I mean, we've got, there's a few out there that do this, but it's just the idea of like a pull versus a push model, right? And you can create your own CRD if you want to that does this. So what are some of the benefits of being able to leverage GitOps? So one of the benefits is you're actually leveraging developer native tooling. So in some blog posts that I've done on Verified GitOps, one of the things I mentioned is that everyone has been doing some level of GitOps since the beginning of source code management, back when they had Mercurial, back when they did SVN, before Git became like the mainstream thing. Everyone was storing a versioned setup of their actual code in some way. That eventually got to the point where we went from just application code itself to maybe some configuration files associated to some scripting tooling that we were using. That obviously broke out into different, change configuration or configuration management tools like a Chef, a Puppet, SaltStack, things along those lines. So everyone has been doing this already in some way, shape, or form. So Git is something that most developers are already comfortable with. So this is a very easy way to do adoption for our users. Another benefit is actually automated recovery. So if we're storing the different configuration files, whether it's infrastructure as code, manifest files, something along those lines, if we're storing that and versioning that in our Git repo, the intent of GitOps is to make the Git repo the source of truth. And then something executes based off of that source of truth. So automated recovery, what the advantage is that if my cluster is intended to be a representation of what's in my Git repo, if something happens in my cluster, that's okay. I can just run what was in my Git repo the last time and spin up a brand new cluster with a brand new setup of the application. That is one of the major benefits of GitOps is you have a very quick and even automated recovery process. Your credential management is not something external typically. You're still running it based off of what you have access to in Git. So if you personally, if your user has already been granted access to a Git repo, even if it's in a process of Git repo where you have access to a specific branch, Whatever your access is, that is the level of credential management you have in your GitOps process, right? So your role-based access control is something that's already built in, typically speaking. You do have git blame and versioning. So if someone fat fingers and hits 23 instead of 2, and they're blowing out the entire cluster because they accidentally added way too many replicas, you can kind of go do a git blame and be like, okay, who was it that actually put the 3 at the end of the 2? Because that's not okay. Which is, again, where the automated recovery would be beneficial. But then you also can version. So if versioning is going to go beyond the idea of like how many replicas are we putting out there, if we've got certain HPAs associated to it, if we're throwing in some like readiness probes or liveness probes, and we know that certain resource configurations are not doing well, either they're under provisioning or over provisioned, then we can actually make a change and quickly get that version to deploy, or we can roll back a version inside of our Git repo and have that auto sync, quote unquote auto sync. And then you also have an easier knowledge transfer. So when you're looking at leveraging developer native tooling, your knowledge transfer is a little bit easier because now I just need to go to my Git repo and understand how my Git repo is, what the hierarchy is. Am I using a mono repo or a poly repo? And then inside of that repo, how does that break down into application code, application configuration code, infrastructure code, things along those lines. So those are some of the benefits. So we're going to go over some of the drawbacks, and at the end of this, we'll cover some of the questions that you guys might have on it, on GitOps at a high level. So the first drawback is auto deployment or auto sync is not actually desired by many companies that are greater than, they have more than 2 customers. And the reason why is if someone accidentally does put in 23 replicas instead of 2, we don't want that hitting production, because on the customer side, now all of a sudden our SLA can go up to like 7 nines because they've got 23 pods to handle the scale. So it's pretty good for the load. But on the business side, we've basically just, thrown out like a 7-digit cost inside of our cloud, which is not good. The other alternative is someone might forget the T in latest, and all of a sudden you have an image pullback error inside my cluster, and now nobody can use it. So you typically run through a merge and approval process. So auto deployment is not actually desired. What we'll do, or what you'll see in the industry or those who are trying to implement GitOps, you'll actually have a process where the kickoff is quote unquote auto synced by having a significant manual step process to get to that final branch of that repo. So you'll still have a lot of manual processes to get there. And then once it's there, it'll auto sync down. The other option is to not use auto sync at all, and you actually use like a CLI or an API webhook that will go and do that deployment for you. So once you run through your CI process and it's ready and good to go and it's been approved, then at the end of the CI process, you'll run a webhook, which will then dictate for that tool, whatever the tool is, to bring that down. There is limited functionality in the CI/CD process. So right now, inside of a Helm chart, inside of Customize, inside of a Kubernetes manifest, you can't tell it to pause for a second and run a test and then wait for an approval or create a Jira ticket or notify Slack. Like, you can't do that inside of a chart right now. I don't think that's going to be something that they're going to implement because of the intention of Helm. But that's some of that limited functionality. So when we understand what the limited functionality is in GitOps, we immediately have to start supplementing some of that automation, because the intent of GitOps is to be automated, right? No one wants to do all of that manually. There is an inherent advanced knowledge requirement outside of what's specifically inside the Git repo. If something breaks, how do I know what to go troubleshoot? If I need to test, how do I go test and then make sure that I've got a consistent process that GitOps works upon? So I actually need to have advanced knowledge of things like Kubernetes and Terraform and how infrastructure as code works and all of these different pieces before I can just set up GitOps. And that actually will come down to the last point on this one. But then there's also limited technology support. Right now, GitOps is only working with Kubernetes. That's it. So if you don't have Kubernetes, you can't use GitOps. If you don't have a cluster, can't use GitOps, right? So that's kind of one of the major drawbacks, is if you're not using Kubernetes in everything enterprise-wide, it's just not going to work. And then if you are using Kubernetes in a portion of it, maybe a portion of your enterprise, but not all of your enterprise, then now you have to weigh the pros and cons of implementing partial process for one thing and not for another thing. And how do you get the training across all of that, right? So there's some issues there. This one is a hidden, kind of like a hidden demon of the GitOps portion, is an easy configuration drift. So hypothetically speaking, we deploy. In that, the case of deployment in GitOps, it's done by someone updating the manifest or like a values YAML or something like that. It gets uploaded into your Git repo. That triggers a deployment down, but something breaks. Well, if that thing breaks, how do we get it to roll back? Because if it's in a broken state and we want to go back and change something, it's not like our GitOps process will just wipe that away and then redeploy. It's going to try to deploy what's already there, which means it's either going to break again or you're going to have something broken that currently lives.
Hey, Bryan, we've got a great question popped up in the chat. It says, I thought GitOps was a concept. Why would it be limited to K8s? Or excuse me, Kubernetes?
Yeah, that's interesting. It's an interesting concept. It's limited to Kubernetes because, first of all, that is the biggest issue when it comes to configuration processes. When we're running a monolith application, the app developers and software engineers, they're only focused on the application code. There's a network team that handles the network process. There's an infrastructure team that handles the server process. There's a database team that handles the database. So you're not really worried about any of that stuff. Once you get into microservices and Kubernetes, now your software engineers are partial network engineers, partial server engineers, partial database engineers, as well as software engineers, right? Because they have to understand not only how their Docker image is going to be leveraged, but also how is it going to be leveraged inside of a like 3-layer abstracted orchestration monstrosity, right? As great as Kubernetes is, it does have some very scary pieces. I guess scary is a good word for it. And so GitOps was a way to prevent some of the issues. Once you get it working right the first time, it prevents some of the issues of how do I train someone to be essentially a CKA so that they can be beneficial to my company. If instead I have a segmented group of people who are CKAs and everybody else just handles their process through CI and then eventually into this GitOps process and sync it down, then that'll make it easier for everybody to be beneficial. And so Kubernetes is the main piece to do that. The reason why it hasn't expanded beyond Kubernetes right now is because there are so many things to tie into. And the real problem is how do you GitOps a process, not how do you GitOps a tool. And so that's another one. Kubernetes is still growing and there's still, I don't know how many people here have implemented OPA and OIDC and ingress controllers and service mesh and stuff like that. So it just grows in its complexity. So if we can have something that maintains that a little bit easier, that would be better. So, so there's that piece. Now the configuration drift, this is another potential issue. And hopefully I answered that question. We're actually going to pause for question and answers right at the end of this list. But configuration drift's another issue. So if you have a failure, how do you remedy that failure using GitOps? The reality is that you need a third party to be your source of truth. So once the third party implements a rollback, if that's what you want to leverage as a rollback, once the third party implements a rollback, then you have to figure out who is it that's in charge of going back and making sure that what's on the cluster that's been rolled back and wasn't rolled back triggered by your Git repo. How do we make sure that that configuration is replicated back into my Git repo? So now we have a configuration drift because my Git repo is supposed to be my source of truth, and it's no longer my source of truth. My cluster is now, or that third party that implemented the rollback. And typically speaking, that third party doesn't have write access to my GitOps or my Git repo. So now there's a huge configuration drift. How long do we want that to live? What's our process of remedying that? How do we do that if we have multiple failures across multiple clusters and multiple applications? There's a lot of potential issues there. And then the last one, and after this, we'll actually pause for some other questions that are there, is the heavy pre-requirements. So one of those is Kubernetes, right? You have to have Kubernetes. You have to have a cluster that's working. And then you also, as a part of your prereqs, you have to have a testing process that is external to your GitOps. You can't test Terraform configuration changes in GitOps because it's going to make an actual effect on what you're trying to do and it's going to break things. So we need to test that out. In the case of Kubernetes, we also need to test that out again. If I need to build my Helm chart from the ground up, or if I need to like script kiddie my Helm chart, how am I going to do that in a test attempt for GitOps? But the reality is that I can't test that. So I need to have an external process to test my my actual manifest. I need to have an external process to test my infrastructure code. Then once it's tested, once it's proved out, once it's scalable, reliable, and repeatable, that's when I'll implement it into my Git repo and then set up a GitOps process around that. So that's kind of some of the heavier prereqs that are there. So we'll pause here. Any questions that were in the chat, Bennett, that we want to walk through? And then once we get those, then if anyone else has any questions on the phone, we can walk through those as well.
No, I think we're all good on the chat this far.
Awesome.
Well, I was wondering, sorry, just on the cluster you talk about. So can you have a GitOps across several clusters, or it has to be several GitOps?
Yeah, that's actually a really good question. Obviously, the desire is not going to match the functionality. So the desire in Kubernetes, in a lot of cases, is to leverage individual namespaces or even individual clusters or cloud accounts entirely to maintain an actual application. And the problem, especially if we're using like multiple namespaces, is that there's no way to do that right now in a GitOps orientation, because GitOps, in the case of push, you either have to script it all yourself, which in that case is not really GitOps. But in a pull model, you can't do that, right? Because everything is located inside of the cluster. So you typically have what's called an application of applications. And then it's, again, formatted in a almost a script it yourself style process. So there's not really anything in the GitOps world that allows you to do one application across multiple clusters in an easy way. It still requires quite an issue with trying to get that set up the first time, and then making sure it's scalable and repeatable. Like, what if you had another cluster? Like, that just kind of breaks stuff. So
yeah,
we did have
we have another question here.
Oh, yeah.
It says, any recommendations around where you would should store your Kubernetes resource definition files? You know, manifest, Helm charts, values, and you know, specifically in a polyrepo environment.
That is entirely dependent on what is called Conway's Law. So I don't know if you guys have ever heard of Conway's Law before, but Damien probably has because he's got a doctorate. So Conway's Law is the idea that the communication of the different pieces of your application will relate to each other, similar to how the communication in your business unit or the business that built the application also communicates. So Conway's Law, in effect, to your Git repo is, if everyone is under a single org and everyone operates as like one big mass of people, then a mono repo is going to match that process. And it's just kind of one of the ways you're going to build it out. Companies that are newer or really going hardcore on adopting a DevOps culture internally, they'll probably enjoy a poly repo a little bit better. There's some better, there's an easier way of doing role-based access control when you're doing a poly repo, but then you have a lot of jumping back and forth between all of these different repos, which is why a mono repo is beneficial. So I would say size of company is a good way of indicating whether or not you should go with a mono repo versus a poly repo. The other one is intent of company and intent of application. If your internal engineers will always be siloed to their individual microservices or applications, polyrepo probably would be better. If you have a buffet style where everybody works on everything, then a monorepo would be better for that. So thanks, Turk. Appreciate that one. And then I see one from Reshma. TF state also stored in the same repo. TF state files. There's not really an issue with storing it in the same Git repo as your infrastructure code. It actually has some benefit to it in the sense that It's easy to version, but it's also difficult to lock. So that's why some will choose things like Terraform Cloud or an S3 bucket, because you can lock it a little bit easier there than inside of a Git repo. There's also a problem with the fact that HashiCorp, in its infinite wisdom, decided for some reason to not make the backend configuration file variableized, which is really weird. So there's a few tools out there that can kind of benefit that, and they implement what's called a dry process, or a don't repeat yourself. So there's not really a problem with storing the state file there. The other thing that you need to consider is the fact that usually the state file is created by Terraform and then sent somewhere. Yeah, so TF state files can have credentials saved and unencrypted. That's that's another really big one. You have to have, basically you have to give TF the ability to write to your Git repo, which is another problem. So Animesh, I really appreciate that call out there. Yeah, credentials unencrypted. I think this is one of the reasons why most companies like to store it in like an encrypted S3 bucket, so at least it's encrypted at rest. And that's really difficult to do in a Git repo. In terms of GitOps, how do people typically handle things like canary deployments and rollback to working configuration? Wouldn't master be updated to the broken config at this point? Any tools can be recommended. Ooh. There is no current way to do GitOps with canary. There are tools out there that are trying to supplement this. Argo rollouts, Argo release. The Argo project, which is a part of the CNCF incubator process, they kind of pride themselves on like one of the main GitOps tools, like Weaveflux is. They really did hit the GitOps ground running, and that's where Argo CD comes into play. And Argo CD is the most true GitOps tool that's out there because they literally only handle GitOps. That's it. That's all they do. When you start getting into Argo rollouts, you start implementing way more than what GitOps allows. And so you're no longer touching GitOps. You're kind of trying to supplement some of the drawbacks of GitOps. So canary deployments, rollback configurations, those are not GitOps native things. That's some of the drawback pieces as well, right? So if you want to go look for another tool to leverage canaries and to leverage things like rollbacks, for a working configuration, what I would recommend is, interestingly, that's one of the things I'll talk about in Verified GitOps, but I would recommend looking at a solution that covers more than just that. If you're looking at GitOps at all, the moment you see a drawback and you want to go, okay, what's that one more thing? It is way better to consider what is the entire thing, and then is GitOps actually enough for what I need versus anything else. Yeah, Argo rollouts is there. So, so the question becomes is just doing canary enough, right? And it's never enough, right? We're software engineers. I mean, it's never enough. So the question becomes is what's the next thing? And then what's the next thing? And what's the next thing? And eventually you get to a full blown solution, right? So if you want to be true GitOps, honestly, canary is something that you kind of have to get rid of. The closest thing you could do would be maybe a service mesh. You could try running a service mesh and using some scripting capabilities around a service mesh. But the reality is that now you're getting outside of the GitOps process. But good one. Yeah, absolutely. Thanks, Dirk. Awesome. Okay. I'm going to jump to a 50,000 foot view. And really what we're going to cover is the pieces of the puzzle. This is what I was talking about, the idea of like that just one more. You will notice this, no hate on Jenkins, but you will notice this if you've used Jenkins internally. Everyone looks at Jenkins and says, great CI tool, we're going to build, we're going to build, we're going to build. And then suddenly someone's like, well, can we do this? I don't know. Let's go check the entire plugin marketplace and see who's actually, building out the plugin. And if there is one, let's see when the last time they built it out and what are the limitations if we use it. Or do I use a shared template and use a shared template library or global template library? Or do I script it myself and make this massive Groovy script repo with all these Jenkins files and things like that, right? And the problem is that no one looks ahead in time and says, well, if we continue down the just one more question path, it's going to get to the just 700 more, right? And eventually you just get this massive monstrosity that runs your infrastructure cost. On just Jenkins alone will run it up into like the $2,000 to $5,000 a month range. And sometimes that's not even the high levels. So what we want to do is, if we can jump back up and take a look at all of the required pieces, usually associated to an SDLC process, your entire CI/CD, what does that actually look like? And then how are we going to solve for it? So this is not necessarily an exhaustive list, but this is a pretty big list. Obviously, we've talked a little bit about code and source code management, but a lot of the pieces that we need to consider is, how are you going to test this? How are you going to build it? What type of artifact are you going to use, and where is it going to be stored, and what platforms and environments, and how are we monitoring when it gets to those environments, and why are we monitoring it that way, and what are my release strategies? So Turkey brought up the idea of canaries. Well, what if blue-green is better for my company? What if rolling is better? You know, if it's a dev environment, do I want to do rolling and then production is do canary? How do I verify that the deployment went successful and there's no actual bugs? If there is a failure, what's the strategy that I want to do, right? Rollbacks are great. However, if I'm doing database schema changes or database migrations, a rollback probably would break more than it helps. So how do I implement a good failure strategy? How do I do secrets management? How do I audit all of this stuff, right? Because let's be honest, when you get to that point where you're asking questions about auditing or get to secrets management, you've got a security team that's already breathing down your neck. You know, how do I report on this? Because my VPs don't care how I'm accomplishing this. They just want to know that I'm accomplishing it, right? So how do I report and get visibility? If I do have something that requires SOX, Sarbanes-Oxley, PCI, PII, PHI, HIPAA, GDPR, I need to have some form of approval process to make sure that things are actually moving the way they're supposed to, and I can report on that. I need to have approvals. How do I get notified when there's issues? Who is in charge of maintaining the process, right? This is just the process. How do I maintain this? How many people do I dictate to maintain this? And then, of course, how do I authorize and how do I authenticate my users? There's a few reasons why I bring this up. Number one is, we have to understand this when we go into our SDLC process. The second thing we have to understand is that there are what are called hard costs and soft costs. Soft costs are rarely considered until everything breaks. So just kind of keep that in mind. Understanding this is what we used to call a CYA. For those of you who have ever worked in a large company, CYA is basically an email thread where you ask for permission and you get it, so you can go back and cover your butt every single time. That's what a CYA is. So how do we cover a CYA, right? And so we want to make sure we have that capability as well. And then your hard cost is, some of these things cannot be done by us simply spending a little bit of time and scripting it, right? And so we have to look at a solution. Do we do open source, or do we do a vendored solution? If we pick open source, what are the soft costs associated to it? How many people are associated? What's the infrastructure requirement? What's the actual requirement on our application? Sometimes that increases latency inside of our application. Are we willing to take that error budget? So there's a few things there. Now, in relation to GitOps, here's what native GitOps does. It grabs your SEM. It will tie into your platform or environment, which is essentially, in this case, just your Kubernetes cluster. So the benefit is that it's platform agnostic. So wherever you have Kubernetes, it doesn't matter. You have your multiple environments, which is great. Your release strategy, which is just rolling. And then your authorization authentication, that is all handled through your Git Repo. So this is really where your native GitOps integrations come into play. The moment you start trying to add anything outside of this, this is no longer GitOps. Now you're looking at an actual tool or solution that can implement GitOps as well as XYZ or whatever it calls, right? So this is where we start to have to consider, if I have all of this, which is great, but the moment I want to add approvals, it's no longer a just one more question. Now I need to have the approvals with the auditing. That's really where the question starts coming in. And so if we start looking at this and say, okay, I just need one more, let's take a step back. Let's evaluate the whole thing and see how we're doing this and where do we want to automate. And if we need to automate all of these pieces to increase mean time to market, if we need to automate all these pieces to, maybe you guys have a massive cloud migration going on, or a huge re-architecture to go from a monolith to a microservice or something along those lines. We need to automate as much of this as possible to be able to hit our deadlines and our timelines and our cost in soft cost and hard cost. we need to start asking questions around what can cover all of it or what can cover most of it, and what we can't cover with a solution, what are we willing to engineer, right? So at this point, if we like all of this and we like what GitOps offers, then we have to engineer the rest, whether that's an actual engineer clicking buttons or someone building it out. So those are the questions that we're going to kind of walk through in the Verified GitOps piece. So Verified GitOps, this is a different topic. Again, unless you've read the blogs that I've written about this, you've probably never heard of Verified GitOps, because there's not many people talking about this until someone actually asks in the chat, like, why doesn't it go beyond Kubernetes? I appreciate that. That was a great setup. And I didn't plant that person, so no one asked any questions. So here's Verified GitOps. Verified GitOps, it's the practice of harmonizing and standardizing tooling and processes to work in tandem. You codify the specifications of the relationships, and then you store that code in a Git repo. So it's more than just the execution capabilities. We need to understand how are these different tools and processes actually relating to each other. So if we look at those pieces of the puzzle and we understand that auditing and authorization and authentication actually needs to be something that's evaluated at each step of my SDLC, how am I actually going to harmonize all of the tools and or processes and how those relate to those different individual pieces? That is a question that I don't think anybody is actually asking. And it's important to kind of jump back a little bit on that piece. So this is a really dumb picture, but it's probably the closest we can get to relating it, right? So we have all of these people, typically speaking, in a business org. You've got your software engineer, you've got your Scrum Master, maybe, or PM, if you want to, use an older term for that. You've got a DevOps engineer, you've got a build and release engineer, or maybe an SRE or QA, and they typically have very siloed processes. How do we actually codify the relationship between all those processes? That's what Verified GitOps is attempting to solve. So here's what it looks like in example. So we had the example of the GitOps, and then here's what Verified GitOps looks like. We have a developer laptop. They go to a Git repo commit. You do code analysis and unit test. You get the build, you merge the approval, and then you build again. Then you upload the artifact, ticket creation, all of these different steps, all the way down to the failure strategy. And guess what? It circles right back up, because we all know that a deployment to production is not at all where it ends, right? I don't think anybody here is like, man, it got into prod, let me wipe off my hands and go home for the night. No, we're typically looking at dashboards or PagerDuty or something along those lines for like hours, hoping, praying that we don't get fired if something bad happens, right? Like that's the typical process. And this is what it essentially looks like. What you're going to see here is actually a breakdown of quite a few different declarative language files associated to it. So we've got a Kubernetes cluster. Well, how are we tying into that Kubernetes cluster? What is it actually going to be used for? So this is the relationship of how we're tying in and relating your Jira, your Artifact, or your Prometheus, your Git connection, your SSH scripts, if we need to run some scripts based like testing or QA. So these are all these different files are actually going to be interrelated to each other, right? And now we've actually documented and codified the relationship between the different pieces of the puzzle. This is just a subsection of those pieces of the puzzle. It gets really heavy when we start looking at it. But this is how I can integrate all of those portions and actually codify the relationship between the different pieces that are there. What this helps us do is understand that there are relationships that make sense, but they're rarely put down on paper. Even if we have a knowledge base, the knowledge base has an almost longer list of exceptions than it does the actual correlation of that relationship. So it's very, very important to understand, can we codify the relationship? If we can, how do we do that? And then how do we leverage it back and forth? So what you'll see here, and this is important to note, these are files that codify a relationship, not an actual process. Then what we'll have is we'll have another file that will actually relate these pieces together. How do I do my deployment to my Kubernetes cluster? And I notify Jira by pulling things from an Artifactory, by leveraging the Git repo to get my Helm charts out of. And then I want to run the verification against a Prometheus process. And then I want to run my SSH install process against maybe a Linux box or something along those lines and run a test against that as well. How do I get these different pieces actually related to each other? right? So we have kind of almost an umbrella file that can do this. So Damien, one of the questions you asked about the GitOps is, how do you run GitOps against multiple clusters? You really can't, especially if you have one application crossing multiple clusters. You have to get really, really, really fancy and a lot of scripting yourself. The advantage of something like Verified GitOps is, if I need to add another cluster, that cluster file on the top left, either depending on the solution that you're going to use, either you just add another set of lines below line 16, or you add another file and you call it cluster 1 and cluster 2. But the advantage is that now that's not a negative configuration ripple change against all of the other files that are here. I just have another process file that says, okay, deploy to cluster 1 and use Jira Artifact, Prometheus, the Git Repo, and then run these tests. And then once you're done, do cluster 2, or run those both in tandem, right? And so now I've got this process of not only executing the process of the relationship, but actually being able to relate all of those different solutions and tools that are there. And so this is essentially what Verified GitOps is intended to solve. So here's some of the benefits for you. So you get all the benefits of GitOps. On top of that, you actually get designated verification steps. So we need to verify that what we're doing is actually correct, whether that's auditability, compliance, ticketing, script running, testing like Selenium or JMeter or whatever the load test might be, or whatever that might be. And then even leveraging something like a Prometheus, a Datadog, a New Relic, a Splunk, whatever those different metrics providers or log aggregation providers are, we want to designate those steps. We want to make sure we pause and give those steps the ability to run before we do anything. We also want to inject approvals if needed. All right. I'm not going to be naive enough to think that everybody is willing to go with what's called no ops, where, whatever's on the developer laptop just gets auto pushed to production. Like, I think like 90% of the companies out there are not okay with going that process. So we need to be able to inject approvals into these different processes, right? And then we also want to skip approvals depending on certain conditions. How do we leverage that relationship? Change management enforcement. This is a really big one. Most of the time we try to implement a change management. Hopefully no one here still has to do change approval boards. If you do, you have my sympathies. I'm very sorry. But how do we actually enforce change management processes? Typically done through something like a Jira, ServiceNow, a Clubhouse, an Azure boards, something along those lines. How do we enforce that that's actually done? Not only that the ticket is created, but that the right amount of information is put into the ticket, so we don't have a whole bunch of templates out there filled with foo and bar everywhere, right? And so how can we best practice the change management by sharing data between those relationships? And then how do we enforce that by just automating the fact that it happens rather than relying on individual people to do it every single time? Testing automation, this is another part of that verification piece. If I've got stuff built out in SonarQube or security scans, image scans, artifact scans, if I need to do any type of code analysis, anything along those lines, as well as my Selenium and my JMeter and all the things that we need to do to make sure that my VP of engineering doesn't come back hard on me because something failed and we didn't test it. How do we actually benefit from leveraging those as automated as possible? So we need a solution that can actually, or at least need a process that can inject those testing automation pieces inside of your process. And then obviously automated failure strategies. There's no one size fits all failure strategy for any company. If you're a startup that was created 6 months ago and you started cloud native and you started in Kubernetes and you're not using stateful sets, then yeah, rollbacks probably will be everything that you need and more. The reality is most companies are not ready for a one size fits all failure strategy. So how do we dictate the difference between the two? Rollbacks for some who can handle the rollback, but maybe I want to pause and wait for somebody to tell me what to do, right? Or tell the process what to do. Or maybe I want to retry the deployment or whatever that might be. Maybe I need to go execute a network switch to flip over to the secondary system and high availability or the DR because something failed horribly. How do I automate that failure strategy? Now there's some drawbacks to this. The first one is there are limited integration points. If you're using a solution or a process that does not have an API or a CLI, you're not really going to be able to do this in a verified GitOps way. You can try to script around it maybe, but if you're using a solution that doesn't have API or CLI, associated to it, you're not going to be able to include that in the verified GitOps because you can't represent that relationship appropriately. The best thing you could do is probably put in, a manual approval step and says, hey, go and do this thing. And then once you're done, come back and approve. And that's the closest you can get. But the reality is that you can't automate that relationship if you don't have an API CLI to integrate with. So that's something that's important. This is the second one, and it's actually probably going to throw a lot of people for a loop considering there is limited/no verified GitOps tooling available. So if you were hoping to find one on this call that does everything, I'm sorry to say that there's not one that exists. There's some that are close. So some that you might be familiar with, depending on how heavy of an engineering lift you want to do. You could use an old school change management solution like a Salt Stack. Some of the ones that are still being developed today is like Ansible and Puppet. You could still use those or use Chef. At that point, you're just running, you're just leveraging them as a script runner, right? And then you're just running these scripts that you've built yourself on the relationship piece. So there's not really, honestly, a lot of any verified GitOps tooling that's out there. Really what you're going to have to do is understand, if you go back to the pieces of the puzzle idea, take this concept of verified GitOps and say, okay, here's my solutions that I'm looking at. Here's where they automate and here's where they don't. Is it worth the engineering lift, right? The soft cost and the hard cost. Is it worth the soft cost and the hard cost to actually leverage this solution, knowing how much I would have to script or build around it, or maybe cobbled together different tools. So it's kind of an important thing to consider is, what is the tooling that's available? What is the spread or the scale that it has in regards to verified GitOps? And then what are my soft costs and hard costs associated to implementing the solution and implementing the workarounds around the solution to fill in where it has holes? Those are honestly the two main drawbacks that are there. So at that point, before I go into CI/CD initiatives and anything else there, what questions would you all have based off of this? I think we have a couple in the chat. Metrics as well. Thanks. Okay. Interesting. Have you defined any schemas for such a verified GitOps approach? It's difficult because, and Turk, thank you. You are my participant of the evening. Well done. So many questions. I love it. It's difficult because it's engine based. What is the engine that you're using to leverage the GitOps or verified GitOps process? I personally like the YAML format because I don't have to, it's easier to read. I'll just put it that way. It's easier to read on the YAML format than it is personally from a JSON format. I would avoid XML as much as possible. And then once you get into that piece of, JSON versus YAML, the schema is really understanding at what point do I have configurability and at what point do I have opinionation. So what I mean by those two is, especially if you're like an administrator for a process or a solution, opinionation is what I enforce using static values. Configurability is what I allow my end user to inject at runtime. So in the case of something like Terraform, I've got variables that can be supplied. How many variables do I want to allow? Because the more variables, the more configurability, which might seem great, but that also gives more freedom to my end users and they can break things and go outside of a desired happy path. So I want to opinionate certain levels, but too much opinionation and I'm actually restricting it down, which causes way too many snowflakes. Again, not to pick on the Jenkins. I just know a lot of people probably have seen or used Jenkins before. It's the idea of how many pipelines in Jenkins do I want to build out or duplicate? The more configuration that I give, the less I have to duplicate, but I also have to have more inherent knowledge on my troubleshooting capabilities. But the more opinionation, the more snowflakes I have, just to kind of meet that happy medium. So the schema I would probably fit into that is, honestly, based off of YAML, I would just do, just honestly basic nesting. I would probably try to limit as much, differences between list and map as possible, because that can actually just be an annoying troubleshooting requirement. So yeah, there's not really a well-defined schema for it. It's honestly based off of the engine that you're using, but that's a good question. Anybody else? Any other questions for this one?
So in the process of GitOps, would you say most people are still under the traditional GitOps and not the verified?
Yeah, I would say, and this actually, Damien, goes back to a question you had on at what point can someone say that they're doing GitOps, right?
Mm-hmm.
And for those of you who are out of the spirited analogy that I brought up about running, because Damien does running, at what level do I say I'm a runner? If I own running shoes and own a running tracksuit and stuff like that, can I say I'm a runner, or do I have to actually be running? And to what extent, right? If I'm running 10 feet versus if I run a mile, like which one indicates that I have crossed that line of runner? In GitOps, I would say to be able to state that you are actually doing GitOps, like the actual approach to GitOps, you have to be implementing your manifests in a Git repo on a regular basis, a repeatable basis, where the process of the push to my Git repo triggers a change in my cluster on a regular cadence. That is when you would be effectively doing GitOps in that specific application. And then if you want to say that your company does GitOps, you literally have to have nothing but GitOps, which is nothing but clusters and nothing but that process. So if you want to be GitOps oriented, that's fine. Most of the time it's not GitOps, it's I'm using a solution that does X, Y, and Z is GitOps, but it does X and Y on top of it or enables GitOps. Yeah, so that's kind of that idea there. Damien, did that answer that question for you?
Yeah, that's fine. Thank you.
Yeah, absolutely. Anybody else? Awesome. All right. So the last piece here is CI/CD initiatives. So these are going to be kind of like 8 common initiatives that are seen across companies right now that have any form of application development internally. It doesn't really matter what you develop. But these are the typical 8 that are always in process. You'll probably see 1, 2, or maybe 3 that your team or your company is currently focused on. Maybe some that you've been focused on before, or some you have never even considered yet. That will most likely be coming down the pipe. So the first one is really democratizing that delivery deployment process. I want as many people doing this as possible. And this is where CI and CD really became, why it became so beneficial. Some of a more traditional mindset were scared of the idea of continuous deployment and continuous delivery because it was seen as, well, if we're just pushing all this stuff out as often as we possibly can, then what's to prevent us from breaking things? And it's like, well, that is a good point, which is why we implement different checks and balances. But the reality is that if you're pushing a deployment that had 1 line of code change, to revert that back is not that bad. If you're pushing a deployment every quarter and you're doing a 10,000 line code change, good luck on the troubleshooting, right? And so what we want to do is if we can enable a self-service capability around our delivery and deployments, now any engineer can deploy or deliver through our delivery or deployment process anytime they have something that's completed. And then we obviously implement those checks and balances. But being able to democratize that allows us to get mean time to market is lowered. And so we can get those features, functionalities out better. The second one is we actually want to modernize our CD system, whether it's continuous delivery and or continuous deployment. So maybe the current process is a massive hairball of extra scripts, extra files, extra plugins, extra tools, and only the, those people who actually understand all of the opening moves of chess that have ever existed can actually figure out all of the different relationships between all the different tools that happen. A really great way of understanding this is implement a failure and see how many people can untangle the knot, right? And if it takes if it can take almost anybody to untangle the knot, then you've got a pretty modern CD process. If there's only like a very small handful of people, like 2 or 5, that can untangle the knot because they know all of the interrelationships between all the systems and tools and processes that work all together and who to call and how to call them and all that stuff, probably need to consider modernizing it a little bit. Standardization, templatization of the deployment pipeline. So we want to reduce the onboarding time. This is onboarding of people and product, right? We can't forget either of those. So if you or your company is currently in the process of breaking your monolith down into microservices, how do you reduce the onboarding time into your CI/CD process? The easiest way to do that is to templatize how you're bringing those or how you're doing your actual deployments and delivery process. The more it's templatized, the faster our onboarding, or the smaller our onboarding time is. And then standardization. If we say you can do X, Y, Z in however many ways you want to, but you have to use our happy path outside of it, we're standardized enough to make it so there's not enough snowflakes to break things, right? And so now we've reduced onboarding time. Maybe you need to increase compliance, security, and governance as every customer or every company grows and they start acquiring customers from different verticals. You'll have different security and governance requirements. Anybody who's worked in startup, you all know, you start out with that one vertical, you've got things going, it's great. Someone has a great idea to go after a government contract. And suddenly it's like, yeah, they're going to pay us like $700,000. Sweet. We need to be, FedRAMP compliant. We have to have an on-premise version of our solution. We need to have PCI PII compliance. We have to be able to enforce segregation of duties. And you're like, oh my gosh, is that even worth it? And that honestly is probably the bane of most startup companies' existence. They just wish that you could deal with PCI and SaaS and be fine. But when we're talking about, especially if, someone adding something like GDPR, or the California equivalent of GDPR, how do we increase the compliance, security, and governance surrounding our SDLC? That might be an initiative that we have to consider. Reduce time to market, especially in the work from home COVID state that everybody is in right now. This is becoming way more prevalent than we'd probably have seen in a long time. How do companies stay relevant in the market and even introduce feature functionality into the market to keep them relevant? Every company thinks that they're maybe too big to fall until a startup comes in and revolutionizes the process and just steals a ton of customers away. And the faster you can have that time to market capability and developer lead time, the easier it is to stay relevant. For those of you who ever read the Phoenix Project, this is essentially one of the main things that drove them to implement DevOps and CI/CD, is the fact that they had a really bad time to market with Project Phoenix. And by the way, if you've been in IT for a while, it's such a funny book. Like, you should totally listen to it on audio tape. It's hilarious. The next one is migration. So a lot of companies are moving to a cloud of some kind, whether that's a private cloud, public cloud, somebody else's data center, essentially. Everyone is seeing the cloud as a huge benefit in so many ways, typically in scalability and reliability than anything else. So if you might have a migration to a public cloud, and that is actually breaking a lot of the CI/CD process because it was built specifically with all of the internal processes and tools and solutions in place right now. It's not as easy just to like flip a switch and now it's like all of a sudden cloud ready. You have to consider so many different things that was never considered before. So now the question becomes, do we rebuild what we've done or try to patch what we currently have, or do we take this opportunity to go and get something new? The other version of migration is migrating to microservices or serverless. What does that actually look like for your company? How do you break that down? And to be honest, the way that you've been deploying monoliths is not going to be the way that you deploy microservices at all. There's so many differences. It's not as simple as just, I'm no longer deploying to a VM. Now I just run kube control apply. It's not that easy. So that could be another initiative. Take a look at this. And then the last one is just reliability. So if we have any people on the call that are DevOps engineers or SREs or anything like that, reliability, obviously a really big deal. Anybody who's in leadership, I'm sure the 4 nines hound is barking at your heels on a consistent basis. Get to 4 nines, get to 4 nines. or 5 nines or any nines or whatever that might be. But just making sure that we have the right reliability for that. So we want to continuously verify that our solution is up, we're pinging it correctly, we're hitting those endpoints, we're deploying often, we have plenty of customers, we have plenty of alerts and notifications that are there. And this is actually, this reliability is kind of breaking into another piece where how do we balance the desire to have reliability, but also optimization, right? If no one cares about their cloud cost, an easy way to get reliability is just spin up a million replicas of everything. You'll never have downtime, right? Because the load will be balanced everywhere. It's great. But your optimization, obviously, you're going to go out of business in about 2 hours. So how do we balance our actual optimization of our cloud cost or our infrastructure cost with the desire to be reliable, right? We have to understand the optimization level or the efficiency of what we're doing to meet both of those requirements. So that's pretty much everything that I was going to cover today. I'd love to, if you guys want to ask any questions. I mean, obviously I've had Harness up there. If you guys want to ask questions about Harness, we can go into that as well if you need to, not a requirement. But any questions on any of the stuff that we've talked tonight or anything like that?
Did you say you had a demo to show or not?
I can show one. I mean, it's really up to anybody on the call. I don't want to, shove sales stuff down anybody's throat. So it's totally up to you guys. If you want to see a demo, I can show you.
Do a demo.
Yeah, I can do that.
I think he's talking about the demo on the GitOps. Is that what you're talking about?
I can show you a demo of what Verified GitOps would look like.
Okay.
Yeah. Let me do that. Let me pull up. Stop sharing for a second and I will share my other screen. There we go. Can everyone see that?
Mm-hmm.
Yep. Okay. Awesome. I do have some stuff that I've built out if anyone wants to take a look at it, PowerShell, all that jazz. So this is the closest that I can get to Verified GitOps. So the idea here would be if I break down a delivery flow, I need to be able to understand how all the different pieces relate to each other. So what I want to be able to do is let's take a more traditional application, right? We're going to get away from the GitOps specific. We're going to go to Verified GitOps itself. So in the case of like a WAR file or a jar file, that's our artifact. How do we get that out there? So the first thing we want to do is dictate what is actually contained and how it needs to be operating in the sense of where it goes and what my install process is. And do I have anything that's specific to my company, or can I just do out of the box stuff that maybe Tomcat recommends, right? So the first one is where am I going to tie into to get that WAR file? So in this case, I've got a project ID, I've got a bucket where my jar is going to live or my WAR file is going to live, and there's my artifact path, right? So I'm going to actually be able to leverage that. The next thing that I actually want to look at is what commands am I going to be required to run this WAR file? Right. So there's my relationship is not just what my artifact is, but how do I get my artifact into the end state that I want it to be in? So the first one is going to be, my install command. Obviously, I'm going to run a specific install process. I have certain commands that are associated to that. And then I want that almost a sequential execution process to understand how that's going to be done. So I'm going to remove some files here. I'm actually going to untar certain pieces. I'm going to make sure that things exist. And then I'm going to change I'm going to do a chmod on that piece itself so I can execute it. And then this is where I'm actually going to be pulling it from once it's on my actual box. Once it's on the box, I need to be able to start it. So here's my process of starting it associated in a YAML format. And then actually what I need to do first, obviously, is stop it. So I need to stop everything, then I need to install it, and then I need to start it. So here's my stop process, right? So I can actually do all of this here. So my install will probably be, actually, I think it's set up this way. Yeah, my install is actually going to run by doing a setup of what's going to happen on the box. Then it's actually going to stop and run that stop command that we had set up before. It's going to do all the copy pieces here, and then it's going to run the start at the end. right? And so this is now my relationship between my start process, my stop process, my artifact itself, and then the actual flow of getting the artifact to work the way it needs to work. The advantage of this is now it's configured. If I need to change anything, I change it here, and I can just have that kind of replicate back up. And I can do that with any type of artifact, right? So I can do that with Lambda, I can do it with ECS, I can do it with whatever the process is and whatever the level of maturity or advanced technology that you're using. The next piece that I want to be able to leverage is something like an environment level. So what does my production actually look like? So, you know, in my production data center or my virtual machine that I'm leveraging, how do I actually integrate with that? What am I going to be using for it? What's my secret without showing my secret? What's my secret that I'm going to be leveraging? What my host names are? All that stuff obviously kind of goes there. And then do I have multiple setups, right? So this is the idea of executing on a Kubernetes cluster, specifically in US East. And then I've got another one in US West. So I have one application. I want to deploy it across multiple Kubernetes clusters. So this is exactly how I define that. And then I'll have a process of deployment that will, or definition of a deployment that will dictate deploy to this Kubernetes cluster and then this other Kubernetes cluster, right? So I'm actually right now dictating how I want to have that relationship set up. Once you got your environment set up done, and you might have some overrides, by the way. So you know, maybe in the case of Helm, we've got some override files that we want to do. We might also have some override files associated to the jar war file, right? So we might want to affect my Catalina file or something along those lines, or my environment variables. And so I might have some that are pre-approved and specific to dev, and I might have some that are pre-approved and specific to production. And that's kind of what that override section is going to be. And I obviously want to relate that to the environment that's there. And then what I want to do is define how it's going to be deployed. And so this is where, let's see. Okay. This is where you get into, and this is a lot deeper than I was actually expecting to go. You have two trains of thought in any type of declarative language nature of any file system ever. You have the one that is, I would rather have everything in one file, even if that file gets to be like 700-800 lines long. The other way of looking at it is, I want to have multiple files that are significantly smaller and reference each other. And there's pros and cons to both. The pro of having one file that's super long, in this case, 341 lines, the pro of having one file like this is I can just read through it and I can see exactly what it's doing. The con is, if I don't have a templatization ability on this, it gets super long and becomes snowflakes. However, if I am using multiple reference files, then this can actually be significantly less, or I should say shorter, not less long, significantly shorter, and then reference other short files. And I can, the only drawback to that is I have to understand the relationship. So I have to be able to say, oh, this is calling this file, this is calling this other file. I need to go to that file and understand what it's trying to do. Right. So in this case, we've got a workflow. We know what we're going to be doing as a rollback. That's going to be our failure type. And then, you know, we've got our notification process, and then our actual phases here. We're actually going to be deploying that out. There's my, you know, it's not really a daemon set in this case. I'm going to be deploying to that VM process. I'm going to be running through the select nodes. I'm making sure this is the ability to codify a check to make sure my VMs exist. Right. So I'm going to codify that check initially. Obviously, I want to do that, or else I'm going to try to deploy to something that doesn't exist. I'm going to disable any services. In this case, we're not. Then we're going to deploy it. How are we deploying it? Okay, we're actually going to run a few things here and leverage what we've got set up. Enable, verify, wrap up. If we're doing an approval, in this case, we are. And then do we have any variables that need to be templatized? In this case, what's the artifact type? What's the value? What's the related field? What's the entity type? You know, there's a lot that's here. So this is another way to make it more configurable and less opinionated, is to allow people to overwrite variables as needed. And then we're going to do another deployment, so we can see that coming out as well. And it just kind of keeps going down and down and down. Do we have any pre-deployment steps? So before we actually get to the point of deploying out the war file, we have to do some artifact checks, make sure the artifact actually exists. We need to do maybe an approval step. In this case, we are. So it's going to approve first, then it's going to do the deploy. If there's a failure, we're going to call the rollback section of this doc. or this configuration file, and this is what we're going to be doing for that rollback piece, right? So we've got all of this capability as well. Do we have any other expressions that are templatized? Yes or no? And then do we have any variables that the user needs to specify as well, right? So there's obviously a lot that's associated to this. And again, this is, which path do you go down? Do we focus on long files that are easier to understand because everything's there? Or do we focus on just making them small files that all relate to each other? So I'm actually referencing a few things in this file specifically. So imagine if all of those other files were added to this, we would easily double the size of this file specifically. And then, depending on all the other pieces you might want to have, you might want to say, how am I going to trigger a deployment? Okay, so I want to actually variabilize that trigger. So I'm going to do it on the webhook when it's closed on the master branch, specifically on a pull request from my GitHub repo, right? So I want to verify that and do that piece itself. And then maybe I want to tie in something like Terraform. So how am I going to tie into Terraform? How am I going to use the variables to tie into Terraform and leverage that as well, right? So as you can see, we're not only doing the individual codification of what the relationship will eventually be or how to leverage the different solutions or tools or processes, but then we're also codifying the relationship of all those tools and processes together. So this is what it looks like when we have the YAML associated to it. If you'd like, I can actually show you what this looks like in real life when we use an engine to deploy, if that's something that people are interested in. And I've got some questions. Let's see. One thing I notice is it gets kind of complex to know the big picture of Kubernetes. Any recommendations for tools for visualizing the resources in a cluster and their relationships? Oof. I would say that is entirely dependent on what you currently have set up and if you want to keep using it. One thing you can use is, Kubernetes actually has a pretty decent dashboard in and of itself. It can get kind of hairy when we're looking at multiple clusters. Another alternative you can have is you can have a export capability that's running on a cluster that pipes information into like a Grafana. You could do that too. There's a couple different solutions, like monitoring solutions out there. Like I think Prometheus has something, Loki has something as well. And then obviously if you're using like a log aggregation, like a Splunk or an Elk or a Sumo, they have some log forwarders. So you can actually go and grab that information and pull that in as well if you need to. And then you can understand that piece. The reality is that the relationship between everything is mainly going to be coming from the source of the action, not the source of the data. Whatever caused the action is going to be obviously the best way to understand what's going to be happening, because you understand what the intent of the action was and what the outcome of the action was. So if you're using a engine of some kind of solution or a tool, make sure that it has proper reporting capabilities, and then you can kind of understand that piece. Can you send the preprint of your next and last Verified GitOps post? We will look practical approaches. Okay, how can you implement it now and what to, yeah. So that's a good question. I've got some posts in Medium that I can share with Damien after this, and then he can send those out as a follow-up, as well as I think this recording is going to go out, so we can maybe add that on YouTube if needed. But I do have some posts on that. What engine is processing these YAMLs? Reminds me a lot of Ansible playbooks, Ansible structures, rules, tasks. Yeah. So this is actually, and I can run an example of this through the engine if you guys would like to see that. I don't want to shove anything salesy down your throat on this one. But this is actually stuff that is auto-generated by Harness for us. So Harness, the company that I work for, solutions architect for, the Harness is a engine or a continuous delivery solution where everything that's done inside of it, outside of like secrets and role-based access control configuration, everything else is actually done in a way where it's converted to a configuration as code YAML on the back end, and you can sync it down to your Git repo. This is actually what this is done here. So if I go and like this was 2 days ago that I was trying to show someone how the GitOps process works. So I actually just changed something really basic and then did a sync up from Harness. So you can actually do a bi-directional sync. So if I wanted to change this, I can absolutely change this and edit this and say, and everyone's going to love the foo and bar on this capability, but we'll do meetup test and foo and bar. And then I'm going to commit that change. So what this will do is it'll actually send this up to Harness. So I can actually change any of the YAML I want to on the Git repo side and actually push that to Harness if I want to. I also have the ability to change thing in the Harness, whether it's the UI in the Harness or there's a YAML editor in the Harness. I can change that in Harness, and then that'll sync down to the Git repo as well, right? So I've got a couple options there. But again, I don't want to shove anything down anyone's throat for salesy, but if you'd like me to execute something so you can see what those relationships looks like, I can do that real quick.
Yeah, then that would be helpful.
Yeah, awesome. Okay, so this is Harness. I had it pulled up just in case. So this is Harness. Inside of Harness, everything is done in that configuration as code capability. So we do this both in the high level setup. So all of the platforms that you're tying into is actually converted to a YAML process. So you can see this is not a GUID. This is actually just a related. It's a random generated piece, but if I change the value, it won't change this. So it's not like base64. So how I tie into, my platforms, how I tie into my artifact servers. So is it going to be Docker? Is it going to be Nexus? Is it going to be JFrog? How am I tying into that? How am I doing this in regards to like Jira or ServiceNow? How are we going to tie into my Git repos? How are we going to tie into something like a Prometheus if I wanted to tie into a Prometheus? And what does that look like? Notification groups as well. Are we using Slack? Are we using emails? And then maybe I've got some tests that are going into place as well. And then the actual application and how those break down, obviously similar to the hierarchy in my Git repo that I showed you guys before. So this is all the code. You can go in here and edit this if you want to. It's totally up to you. And you can actually limit this down to who has access to which one. That's kind of broken out into Harness as well. But what I'll do is I'm going to do a deployment that's going to show you the breadth of what Verified GitOps should intend to do, which is this all services based deployment. So this whole pipeline is actually, anytime you see this little Git icon or code icon up here, you can actually see the relative code associated to it. So here's the pipeline. We're going to do an IIS-based deployment to and Kubernetes and PCF and Tomcat on Linux and Lambda with Terraform, and we're going to be running an AMI deployment as well. And we're going to run all of these in parallel. And so this is where that configurability versus opinionation comes into play. Right now, this is extremely opinionated. I only have the ability to select which version of the artifact I'm deploying. So in the case of Lambda, in the case of AMI, we're going to give you a list of all the available version numbers or build tags that are associated to that artifact high level. Again, this is extremely opinionated. It's just for a demo purpose rather than something that you can get very granular into your configurability. And then we'll see this deployment go out. So again, here's the pipeline across the top. Each execution actually has a high-level metadata associated to it. So here's the case of IIS. Again, we're going to start out by making sure that the nodes exist, and then we're going to run our deployment. And this is not a black box. You actually get all the what we're deploying, how we're deploying at, everything like that. And we actually break it down individual steps because it makes troubleshooting significantly easier. You can actually understand, okay, where did my initialize phase, which is basically how do I set my working directory and how do I, remote in essentially is how I'm doing that. In the case of Kubernetes, and this workflow will actually go a little bit deeper into some of the other pieces. I'm starting in this case with a Jira ticket. So I'm actually creating a Jira ticket using Harness. And again, this is all configurable as code as needed. But I can inject this Jira process here and make a best practice around my compliance and auditing, and then ServiceNow. And then I'm actually going to do a SonarQube artifact scan on the actual Docker image. Once that's done, I'm going to do a deployment. And again, I can see what I'm deploying. So here's the manifest, and here's the secret, for example. Like you won't be able to get the secret from Harness. It's one of the things that we do. Here's what we're deploying, and then you actually get the how we're executing it. So here's the kube control commands directly. You can actually download this and run it yourself if you wanted to. It's pretty simple. And then wrap up, we're just updating the Jira ticket at the end to say it's ready to go for testing. Linux boxes, doing the same thing, running that select nodes, make sure they're there, running the install process, make sure everything runs correctly. Obviously, with Tomcat, it's a little bit heavier, but it's all right. And then in this case, we're just running a basic hello world example. So we're just hitting an endpoint to make sure it exists and it's good. Lambda, Terraform, how do we tie in Terraform and infrastructure infrastructure as code. So we're running a Terraform plan. Here's the output in the dry run. We're running a Terraform apply. And then once that's done, we're actually deploying our Lambda piece as well. So you can see Lambda being done. So not only did we affect where we are going to deploy Lambda, but then we also deployed Lambda. And then you obviously have the AMI that's going out, and then you still have the IIS because it's Windows and it's Windows. So if I wanted to drill down into this, here's the Kubernetes breakdown. I can see those individual steps as needed, and I can see the code associated to that. So here's all the code associated to this workflow. And if I wanted to go to that specified service, I can see here's the Kubernetes manifests. If I wanted to, I can reference the manifests that I have in Helm charts or customization from my Git repo if I wanted to do that. And again, I can just go look at the config as code icon in the upper right and see the relative files associated to it. So deployment YAML, namespace YAML, values YAML, all this stuff exists in my Git repo, and I can sync that down and sync it up and all that stuff. So here's how Harness actually integrates all those different portions of that piece together. When I said before there's limited verified GitOps tooling, Harness is one of the closer options. Again, it depends on how much engineering you want to do, engineering lift. Harness doesn't do continuous integration, so that is an area where Harness does not operate verified GitOps on. So as I mentioned, it's limited. Harness does not even do full verified GitOps. We're close, but we're not 100% there. And then obviously, Turk, you asked questions about how can I see relationships between different pieces. So I want to be able to see all my deployments that I've done. I want to see what's active. I want to see what currently exists out there. So let's look at something that's a little bit older, maybe not Kubernetes. So I've got 4 instances of that artifact that exists. Here's how many versions, here's the environment, here's the different infrastructures I'm deploying to, instances of the version in the environment, and then the history of how that has been operating. I can see that across a whole lot of setups. And then I also have the ability to slice and dice any of this data in any way, shape, or form that I want to. So right now, all these service is actually taking a very long time for lead time to production. And so now you've got repeatability, you've got reliability, you've got scalability, and now you've also got observability tied in. There's a whole security portion that we haven't even gone into yet too, but that's the idea of just having it there and then being able to execute that based off of the engine. So Turk, you're right, there is some correlation between what an Ansible playbook could be. I mean, Chef cookbooks, same way, Puppet's configuration style stuff. The question that becomes there is how much is going to be native and how much is going to be engineering, right? So if I go and change anything about the order service or anything about the deployment process itself inside of the UI, it actually is going to auto convert that into YAML and send it down. Whereas in something like an Ansible or something like a Chef or a Puppet, you don't really get that capability. You have to go and engineer that, and then you have to construct how you're going to leverage the configuration portion, and then you have to sync that up, and then you kind of have to maintain that process. So a couple questions. BioBreak, I like this status visualization nicer than Jenkins. Well, thank you. Does this tie in with Tower, Ansible Tower? You can execute Ansible Tower from Harness if you want to. Honestly, at that point, I would start to question what is an overlap, right? If you've got the Venn diagram up of different solutions in the overlap, you want as little overlap as possible. You want them basically complementing each other. Eventually, the Venn diagram gets so overlapped that the differences is really just like name and maybe color scheme. And so, go back to pieces of the puzzle, try to understand what that looks like. And then is it worth it to, adopt a new solution, and how does that actually work together? And what does the current solution lack that maybe a new solution would be beneficial? And once we understand that, does it make sense to move off if needed, or reduce if needed, right? So for example, Jenkins, we don't replace Jenkins 100% because Jenkins is a CI tool and it's really good at CI. We use Jenkins internally for CI. But what Jenkins doesn't do really well is deployments, because it wasn't intended to do deployments. At that point, you're doing a ton of plugins, a ton of Jenkins files, Groovy scripts, shared template libraries, global template libraries, all that stuff that you're still engineering, you're still trying to maintain and process and all that jazz. So what we say when we're talking with someone who's got a pretty heavy Jenkins operation is don't eliminate it, just scale it back to what it's really good at, and then use Harness for the rest of it and just automate the interaction between the two. And we do actually integrate with Jenkins as well. So So there's a lot of options there. But that's about everything.
All right. How do we get started with Harness? Is there a free account to get started?
Oh yeah, absolutely. So there's some really great options for you. You can always go to harness.io if you want to use Harness. There's a get started section up here in the top right, and you can just start out with Harness and you're good to go. If you guys would like to have any more information, I actually work on that process as well as helping companies through POCs and also onboarding. I do both. So if you'd like to work with me directly, let me know. And then, we've got Damien, I think we can share out some contact information afterwards with Bennett and myself. But just let us know and we'll make sure that we direct you appropriately to the right team. One of the things that we do when we're working through a POC is we'll actually set up a Slack channel. I pretty much live on Slack because I've got it everywhere. But we'll set up a Slack channel so we can communicate that way. It's way better than just jumping on a million phone calls. And then also the onboarding process I help you with as well. So if you want to get started on your own, just go harness.io, get started, sign up. You get a 14-day free trial. It's all there for you. We also have Harness Community, which I do a significant amount of contribution to. So there's a community Slack channel, as you can see, community forum. You've got Harness experts, select group of people from Harness or users of Harness that have been kind of elected in a sense as people have used Harness enough to be experts. They can contribute things there, build on Harness. I did one on the local Go templating process. I've done one on integration points. There's a ton of stuff. So community.harness.io, you can sign up for our Slack and talk with us through there if you need to. Harness.io, get started if you want to do something there, or contact myself or Bennett, and we can walk through that as well.